Hi everyone. In last class, we have discussed regarding introduction to control system and also we have discussed regarding classification of control system. So today we shall discuss regarding the mathematical model of a physical system. In that, modeling of a mechanical system elements. So mechanical system motion can be of different types. That is translational and rotational, or it may be a combination of both. Okay. So the equations governing such motion in mechanical system are directly or indirectly it is governed by Newton's laws of motion. Newton's laws of motion for translation system. So what it states is the algebraic sum of forces acting on a rigid body in a given direction, that is equals to what? That is equals to the product of the mass of the body and its acceleration. So what it is saying, Newton's laws of motion for translation system. Okay. So it is a forces, summation of forces that is equals to m indicates mass and a of t, that is acceleration. Force is equal to what? M into a usually divide. So here summation of all the forces equals to m into a of t. That can be written as what? M into dv of t divided by dt. That is equals to m into d square x of t divided by dt square, where m denotes the mass of the body and a of t is the acceleration of the body in the direction, and v of t is the linear velocity of the body and x of t is the displacement of the body. Next, mechanical translational system are modeled by three ideal elements. They are mass, spring and damper element. We can call it as friction also here instead of damper. First, mass. Okay, mass is considered as property of an element that stores the kinetic energy. One thing you need to remember is mass stores the kinetic energy of a translation motion. And here m is equal to omega divided by g or w divided by g. W indicates what? Weight of a body, and g is nothing but a acceleration of free fall of a body due to what? Due to gravity. One end of mass is always connected to the ground. So this is the physical system. We can say m, that mass one end is connected to reference, we can say ground. So one is force f of t and x of t is displacement, v of t is a velocity, and f is equal to m dv divided by dt, that is equals to m d square x divided by dt square. Next is a linear spring. Here linear spring may be a model of natural spring or it is a cable or belt. So in general, it stores a potential energy. Linear spring will store what? It stores a potential energy. All springs in real life are non-linear to some extent. So the linear spring symbol is like this. It indicates, we indicate in terms of what? In terms of K. Okay. So here they have given two displacement, that is x1 of 2, x2 of 2 and v1 of t and v2 of t. So what we can write the equation? F is equal to k of x1 minus x2, that is equal to k into x. In voltage, that is in velocity term, k is equal to integration of minus infinity to t, v1 minus v2 into dt. So this in terms of displacement, this in terms of velocity. Next is friction. When there is a motion or tendency of motion. So when there is a motion or tendency of motion between two physical elements, frictional force exists. There are three different types here: viscous friction, static friction, Coulomb friction. So what is a Coulomb friction? This is the force of sliding friction between dry surfaces. And viscous friction, we can say the example ship and ocean and ship. Okay. Ocean and ship. for viscous friction. This is the force of friction between moving surface separated by a viscous fluid, or the force between a solid body and a fluid medium. Next, we can call it as static or friction. This is the force required to initiate motion between two contacting surface. This force is required to initiate the motion. Okay, there is a force is required for movement. Okay, so this is the force required to initiate motion between two contacting surface. You can say example, that is book on the table. So if you want to move book on the table, so we need to apply some force. Next is a damper element. We can call it as a friction or damper element. This symbol indicates damper. Okay, the symbol indicates damper, and we indicate as a F. We indicate this as B. Okay, so here F is equal to F of or V1 minus V2 is equal to F into V, and F of X1 dot minus X2 dot, that is equals to F into X. The units are like this. X we indicates in terms of meter, V indicates in terms of meters per second, and M indicates kg, and force is Newton, and K is newtons per meter, and F is newtons per meter per seconds. Okay. Newton's laws of motion for rotational system states that algebraic sum of moments or torques about a fixed axis is equal to the product of the inertia and the angular acceleration. Similarly, instead of m, we write torque. Instead of here instead of force, we have written torque, and instead of m, we have written inertia. Okay, so inertia into acceleration. That can be written as what? J d omega of t divided by dt, that is equal to J d square theta of t divided by dt square. So this is nothing but x of t. Okay, theta indicates x here, angular displacement it is, and omega indicates here angular velocity, and alpha we can write in terms of alpha r a. Okay, that is angular acceleration in rotational system. So similarly, mechanical rotational system are modeled by three ideal, that is inertia, torsional spring, and damper element. Same inertia, it will store a kinetic energy, and torsional spring will store a potential energy, and it will be like rod or shaft when it is subjected to an applied torque. It is a spring constant. K can be device to represent the compliance of a rod or a shaft when it is subjected to an applied torque. Next, friction, same, three types. That is Coulomb friction, viscous friction, and stiction friction. And out of these three, viscous friction is the dominant one. Inertia element, like this we will write. Okay, one inertia is one end is connected to reference, and here omega is nothing but what? B, and theta is nothing but x. So we shall write the equation for torque. T is equal to J d omega divided by dt, that is equal to J d square theta divided by dt square. Next, torsional spring. T is equal to K into T1 minus T2, theta 1 minus theta 2. That is equals to K minus infinity 2 to T omega 1 minus omega 2 into dt. So we have written in terms of displacement and in terms of velocity also. Next, a damper element. This symbol is damper element symbol. T is equal to what we can write? F into omega 1 minus omega 2, that is equals to F of omega, and F of theta 1 dot. Theta 1 dot indicates this is differentiation is there. Okay. Theta 1 minus theta 2. Theta 1 dot minus theta 2 dot. That is equals to F of theta dot. The units are like this: theta radians, omega radians per second, J is kg meter square, and torque is Newton meter, K is Newton meter per radians, and F is Newton meter per radians per seconds. The translational and rotational, we shall compare. Here mass is there, and here inertia, and here also friction, here also friction, we can write. Swing, spring, and here translational, here force we will consider, and here we will consider the torque. Okay, and here displacement we indicate in the x, here theta, and velocity we indicate v is equal to dx divided by dt, and here omega is equal to d theta divided by dt, and acceleration is nothing but d square x divided by dt square, and angular acceleration is nothing but alpha is equal to d square theta divided by dt square. Next, important for problems. This is important for problems. The term for an element connected to node X and stationary surface. So you can observe it is a mass is connected for X of t, and it is connected to ground also. So for mass, what we can write the equivalent system. So like this, X of t, for X of t, a m is connected. So equation is m d square x divided by dt square. Friction b into dx divided by dt. So they indicate like this, friction b. So this is the symbol. X of t is connected for friction, and it is for ground also. So we can write here also mass. Here we can write mass. Okay. From mass we can give the connection to the friction. Next, for spring, kx, swing to mass, and x of t, and it is f of t. So what we can write here also, we can mention the mass. Okay, x of t is connected for spring. Term for an element connected between two nodes, that is x1, x2. Okay, so x1, x2. So here for M1, X2 is connected, for M2, X1 is connected, and in between there is a friction. There is a friction B. So what we can write is, that is this circuit we call it as physical. This circuit is called it as physical system. This we can write it as a mechanical system. That is equivalent system. Okay. So x1 of t is connected for M2, and it is also connected for friction. And x2 of t is connected for M1, and also it is connected for B. So B is between x1 of t and x2 of t. Next, for this, what we can write the equation for friction: B dx1 divided by dt minus dx2 divided by dt. And next is spring K. So what we can write for x1 of t, m2 is connected and k is also connected. And for x2 of t, m1 is connected and k1 is connected. So what we can write the equation: k of x1 minus x2. No mass can be between the two nodes, as due to mass there cannot be a change in force, as mass cannot store a potential energy. Next is all elements which are under the influence of same displacement get connected in a parallel under that node, indicating the corresponding displacement. This is the diagram, physical system. M and beta and k, they have given ground also. So for x of x, mass is connected. One thing is k is connected, also B is connected. Spring and friction is connected. So this is the equivalent circuit for this. Equivalent